Process of writing structural formula from the IUPAC name of organic compounds. In this video lecture we discuss about this topic, so this video is going to be very interesting and important for you. If you are the beginner of organic chemistry, then this video will help you to understand that how to write structural formula of organic compound from its IUPAC nomenclature or from its IUPAC name. Hello everybody, I am Atanu Betal. You are welcome to this channel. Right now we discuss about this topic, and before starting discussions regarding this topic, I would like to remind you that if you are new to this channel or you do not subscribe this channel, then it's the time to subscribe and press the bell button to get the new video upload notifications. So let's start our discussions regarding this topic, that what are the processes or procedures for writing the IUPAC name to the structure of organic compounds. You know, some two examples here. Two examples are given here. 5-hydroxy 2,3-dimethyl hept 3-in-L. This is an organic compound, so we have to understand the process for writing the structure of this organic compound. This is the IUPAC name of this organic compound. So right now we learn that how to write the structural formula of this organic compounds. At first we solve this problem number 1. The process is, at first we have to note the root word that is written in the IUPAC name. Okay, here we are finding the root word hept, which is which defines that the number of carbon atoms that are present in this organic compound is 7. So we have to write a chain of 7 carbon atoms. Okay, so we are writing the chain of 1, 2, 3, 4, 5, 6, 7. So 7 carbon atom chain, because we are finding a root word hept here. So our chain number of carbon atoms that present in chain should be 7. So we are writing the 7 carbon chain. After that we have to note or you can number it. Next step, you can number it. At first we are noting the root word that is hept, so we are writing 7 carbons in the chain, and after that we have to number the carbon atoms. As like numbering step, we can number from any side, from this side and from this side also. So we are numbering it from left to right side. 1, 2, 3, 4, 5, 6 and 7. 7 carbon atoms are present in this organic compound, so we are writing the chain of 7 carbon atoms. Now we have to find the substituents that are present in the respective numbers. Like at first 5-hydroxy means 5 position is this one, and we know that hydroxy means OH group. So hydroxy is in the present in the 5 position. So next 2,3-dimethyl. Okay, 2 position is this one, here 1 methyl. 3 position is this one, here another 1 methyl. So we are writing up to here 2,3-dimethyl hept. So we are writing up to 2,3-dimethyl hept. Now we next need to write the 3-in-L position. 3 means this position and 3-in means here, in means a double bond. So 3-in means 3 position, in the 3 position a double bond present, so 3-in. So we are writing up to here, and next L is the suffix for aldehyde. aldehyde, so one position is occupied by, or in the one position we have to write the functional group aldehyde, that is CHO. CHO means L, because we know the C for CHO the suffix is L. So the total name is completed right now up to here, and the structure is not completed here because we are seeing the valency. Less valencies are not satisfied here in some positions, like in two position carbon completes its 3 valency, where we have to complete 4 valency because of tetravalency of carbon must satisfy 4 valency. So here we have to write 1 hydrogen to satisfy the tetravalency of carbon. Next we have to write here 1 hydrogen, because 2, 3 and 4 valency completed by adding 1 hydrogen atom here. In the 5 position also we have to add 1 hydrogen, because its 3 valencies are completed, 1 valency does not satisfy, so we have to satisfy the 4 valency using 1 hydrogen atom. Next, in the 6th position we are seeing we have to provide 2 hydrogen atom to satisfy the 4 valency of carbon, so that is CH2. And in the 7th position we have to write 3 hydrogen atom, that is CH3, to satisfy the carbon atoms, valency of carbon atoms 4. So this is the overall structure of this compound. IUPAC name is as 5-hydroxy 2,3-dimethyl hept 3-in-L. For this organic compound, IUPAC name of this organic compound, the structure of this organic compound, structural formula of this organic compound is this one, where we are seeing that 5 position occupied by hydroxy, 2,3-dimethyl, 2 and 3 position occupied by 2 methyl groups, and hept means total number of carbon 7 carbons present in this organic compound, 3 position occupied by 3 position, in the 3 position a double bond present because of the in suffix, and L 3 in 1 L, actually it is 1 L, 3 in 1 L, and one position is one position, in the one position one functional group present, and that's the aldehyde functional group. So the name is like this and the structure is this one. Next we have to write the structure of the second compound. I think you understand the first compound, how to write the structural formula from its IUPAC name, means from the IUPAC name of the first compound. For the second compound we write the IUPAC name. At first we have to notice the root word that is present in this IUPAC name. It is paint. Paint is the root word that is present in this organic compound's name. So paint is the root word. We have to write 5 carbon atoms, because here the root word is paint. 1, 2, 3, 4, 5, and after writing the 5 carbon atoms chain of 5 carbon atoms, you have to number this chain from any side, from this side to this side, or from this side to this side, any one is correct. So we see here the root word is paint, and we are writing the 5 carbons chain 1, 2, 3, 4 and 5. Okay, next we have to do the position of the substituents. We have to place the substituents in the positions, like 4-hydroxy means 4 position is this one. This one is a hydroxy group is substituted at the 4 number carbon atom. Next is 2-methyl, and this 2 position we filled 1 methyl, so we are writing 4-hydroxy 2-methyl pent. Up to here we are making the structure of 4-hydroxy 2-methyl pent. At first we are writing pent 5 carbons, then we are writing 2-methyl, means this one, then 4-hydroxy. Okay, up to here we are completed. And then in pentane means all the 5 carbon atoms are only have the single bonds, that is meaning by an pentane. It's meaning that, or it means that all the carbon atoms are joined by carbon single bonds only. Here these 5 carbon atoms are joined by carbon single bonds only because of the suffix n and pentane an. So because of the an suffix here, all the carbon atoms contain the single carbon bonds only. Next, oic acid. Oic acid means carboxylic acid, and 1 oic acid, pentanoic acid or pentan 1 oic acid. So one position, in the one position we have to write the functional group oic acid. Oic acid in the first position, pentanoic acid, first carbon atom, because of pentan 1 oic acid. So in the first carbon we have to write this functional group carboxylic acid, pentanoic this one carboxylic acid COOH group. So now up to this acid steps, full meaning of this name or full structure is completed. But right now look at the valencies of each carbon atom in this structure, and we are seeing that the valencies of each carbon atoms in this structure is not completed. So we have to complete the valencies of each carbon atom, four valency or tetravalency of carbon, by filling with hydrogen. So here we are seeing that 3 hydrogens required, because to fill up the valency of 4, 1 valency completed, so 3 hydrogens required. For the carbon number 4, 1 hydrogen required, and for the carbon number 3 there is 2 hydrogens required for this carbon number 3, and for carbon number 2 we are saying the 1 hydrogen is required. And after filling all the deficiencies of the hydrogen or or incomplete valencies by hydrogen, incomplete valencies of carbon by hydrogen, the structure is now complete, and the 4-hydroxy 2-methyl pentanoic acid means the structural formula of this one is the structural formula of the 4-hydroxy 2-methyl pentanoic acid. So this is the process of writing the structural formula from the IUPAC name of organic compounds. I think you understand this process of writing this structure. So still, if you have any questions regarding these discussions, then you can ask me directly in the comment section below. And I also like to request you that you after watching these discussions, you can comment that how do you like this discussion. So that's the discussions right now. Don't forget to subscribe this channel and press the bell button, and thanks for watching this discussion.